Okay, so yesterday we finished looking at the consumption function. If you remember, we said that aggregate demand was equal to consumption plus investment plus government expenditure. So we already saw what was the consumption function, so today we will see the investment function. Okay. First of all, let's define what is an investment. How can I understand if a certain purchase is consumption or investment? What is the main factor that makes you understand this difference? Is it consumption or is it investment?
Investment.
What makes you understand this difference? If I buy food, is consumption or investment? If I buy a jumper, is consumption or investment? Consumption. If I buy a car, is consumption or investment?
Investment.
If I buy a house, is consumption or investment? Right. If I go to a restaurant, is consumption or investment? Consumption. Okay. If I buy a machinery, is consumption or investment? Okay, good. So you can make a difference depending from what you make this difference.
You make money.
Ah, for the amount of money you spend, correct? Investment involves loads of money. So when we think about investment, we think about loads of money. I need to spend a lot. If you remember the first lesson, we said also consumers sometimes made investments, but very seldomly. You can buy a house once in your life, twice, 3 times in your life. You change your car once every 10 years, right? While the main operator that do investment is the companies. A company makes investments more frequently. Change machinery and have to buy good amount of goods. So we define investment as a purchase that involves lots of money. So normally, when you need to spend a lot of money, think about yourself. You need to buy a house. What do? Normally, people has all the money they need.
No.
Ah. So, loans. But normally, you need to borrow money. So, since investments involves lots of money, normally to do an investment, you need to borrow money, right? To borrow money. When you borrow money from somebody, usually from who you borrow money? From a bank. When you borrow money from a bank, is it for free?
Interest.
Very good. Normally you have to pay an interest rate.
You okay?
Normally you need to pay an interest rate. If interest rate is high, let's say interest rate 20% or interest rate 2%, you will be more keen on borrowing money when the interest rate is 20 or when it's 2? 2. You all agree with this. So the lower is the interest rate, the more people will be keen on borrowing money, so they will keen on investing. If interest rate is very low, you can think about, oh, I can make a loan and buy a house as an investment and rent it, etc. But if interest rate is very high, you probably won't even buy your house for yourself because it costs too much. Clear? It's clear for everybody this? Okay, so we have an inverse proportionality between interest rate and investment. So, if interest rate is high, investments get down. If interest rate is low, investment increases. Okay, an inverse proportionality. So, if we have to build the investment function, we already know we have a minus sign closer to interest rate. Now, we need to put 2 other bricks in it. If you remember last time, we were talking about the propension to consume, right? How much people was sensible to consumption, was keen on consuming. When we talk about investments, also thinking about even single person, each one is differently sensible to variation of interest rate. Okay, there will be people that for an increase of an interest rate they will stop borrowing money and stop investment because it's too risky, right? Other people less. So there is another parameter like the little c we saw for consumption, even for investment. This parameter is called B, and it is the investment sensibility to interest rate variation. Okay? B, as well as it was C before, is a data that is available for each country, right? And it is the sensibility of the operators, so of the companies, to variation of interest rate. There are countries very attentive to the financial market, and that for little variation of the interest rate, they stop or increase their investments. Other countries that are less sensible to this variation, okay, less attentive. Is it very clear? Hmm? For everybody? Tell me. Okay? Investment sensibility to interest rate variation. Now, think about a company. If I decide I want to increase my production capacity, right? I want to buy new machinery because I want to increase my possibility of production. Sure that if interest rate is very high, I probably wait for better time. You agree with me? But what happens if a machinery breaks? I am anyway compelled to change it, right? I have to change it. I must change it, correct? So inside the companies, there are a certain amount of investments that, never mind how much is the interest rate, companies has to do it. For instance, things about all these cases where I need to change some machinery, I need to change computers inside my offices. Not because I want to renovate, but because they are not working anymore. And they give me problem, or they are too old and my production doesn't go as well as it should. So there are some investments that can wait for better times, but some other investment cannot. So also for investment we have I0 that are independent investments. So these are independent investments, and these investments does not depend from interest rate variation. Those are the investments that companies must do anyway. They are obliged to do, they are compelled to do it. Correct? I give you good news. We are not drawing this function. I was sure you were happy. Last parameter was government expenditure. Up to you. Just connect your neurons. Up to you. The amount of money spent by government depends from what?
From the net taxes.
From the amount of taxes they get, that's for sure. Yeah, from the amount of taxes is correct. But the fact that government decided to invest money in school or in hospitals or in railways or wherever, from what does it depend? Who decides where to spend money? Because the amount of money is the amount of money they get from taxes, right? And this is the amount of money they have to spend. But the fact of spending them, I don't know, for the poor people, or for building a new school, or for constructing new motorways? Who is deciding it? Huh?
State.
The state, correct? And more precisely? Huh? No, try it. Try it. Today in Italy, who is deciding? What's the name? Uh, not the President of the Republic, because he doesn't have any power, but who is deciding? What is the name of the G? Government expenditure. So who is decided today as the head of the government? But the fact that the government decided to do more investment, less investment, to consume and buy new things, depends from the government, and the government depends from the politics. The fact that it is this head of government of this other head of government changing the political parties, they change the way they spend the money. Correct? So, government expenditure depends from politics. And as you may imagine, politics is not a measurable factor, right? So, we have then completed our aggregate demand function. Because now we know. Last thing. We will not draw it on a Cartesian plan, but if we would, what would be the name of this axis?
E.
And what will be the name of this axis?
B. E. E.
Okay? So, little I is the independent variable, and big I is the dependent variable, because this function is telling us how the investments variate due to a variation of investment rate. Okay? So, having it in the back of your mind, we can now draw the full equation of aggregate demand. Consumption, we now know what it is, as C0 plus little c, y minus t, plus, now we know also I what it is, I0 minus bi plus g, okay? Now, if we should draw it on a Cartesian plan, the name of this axe, I think, is clear for everybody. What's the name of this axe?
AD.
AD. Good. And what's the name of this axe?
G.
In the consumption function, what was the parameter? Income. Correct? because this was a number, this was a number, this was a number. In the interest function, what was the parameter? Interest rate. Huh? This was a number, this was a number. Government expenditure has no parameters. We said it's a data because it depends from politics. So we have a big problem here. Because we have for sure aggregate demand here. But on the x-axis, we don't know what to put. We have 3 variables. So of course Keynes could have drawn a Cartesian plan with 3 variables, which was a little bit complicated, but decided to make a choice. Since he had to analyze 2 different markets, the goods market, the real market that we are looking at now, and the financial market. So he said, for the good market, definitely national income is the most important parameter. While from the financial market, definitely interest rate is going to be the most important parameter. So to study at best the goods market, we will consider investment as a data. We will not consider investment as a function of interest rate, but we will consider it as a data. Then I'm sure you are asking yourself why then I have started explaining all this, because it will be helpful in a couple of months. Okay? But for the moment, we will leave with investment as a data. Correct? So, we have solved our problem. We know that in here we have Y, aggregate demand and income. So, the aggregate demand function, which is the equilibrium in the real market, tell us how variate the aggregate demand due to a variation of the income. His function is then going to be C0 plus little cy minus t plus E plus G. Okay? So E and G has this on their heads, meaning that they are fixed value, right? So, now I will do for you, but try to do also by yourself, knowing that our 2 incognitas are aggregate demand and income, and that this, and this are number, try and solve the function. I will do on the blackboard. But try and do it by yourself. Of course, the first thing you need to do is to solve the parentheses and to put all together the numbers. Okay? Try and do by yourself, and I will do it for you on the blackboard. Some of you have succeeded in this very difficult mathematical operation. We have solved the parentheses and we have put all together the letters that are numbers. C0 is a number, minus CT is a number, this is a number, this is a number. This is the independent variable with its parameter. Quite clear up to here? You are done? So, I put all these that are number in a square, in a rectangle. We can call them A, or we can leave them like this, as we prefer. But we know one day when we will have data, this will be a number. This will be 0 point something multiplied by y. So the graphic representation of this function, what will it be? An hyperbole? A straight line, correct? And what will be the intercept? The intercept, Q. What will it be? A. Okay? So C0 minus CT plus E plus G. What will be the slope of this straight line? Little c. The straight line this is y, this is q, this is m, and this is x. Okay? So the slope will be little c, propension to consume. So this is going to be the intercept, and this will be the slope. Yeah. So I think it's easy to understand that if one of these factors increases, if C0 or I or G increases, the straight line will go up in parallel, and if it decreases, will go down in parallel. While if we have a variation of propension to consume, this will change its inclination. Okay. Now, if you go back with your mind to the first episode of this series, we said that aggregate demand has all the goods and services bought in a country, correct? You remember it? Good. So, since it's all the goods and services bought in a country, this was equal to what?
To the gross domestic product.
To the GDP, to the gross domestic product. And the gross domestic product was equal to national income. Wow. But we do have national income here. So we know that the equilibrium in the goods market is when aggregate demand is equal to national income. Because that's the definition of aggregate demand. So, if the goods market is in equilibrium, it means that aggregate demand is equal to national income. Correct? But I think that you know what is the graphic representation of this. Right. A straight line. A straight line. And more precisely, which kind of straight line? It has a name. The straight line that in math has y equal to x. Yes, the bisect. Okay, so the bisect of Q1 represents the equilibrium in the goods market. So all the points that are on this straight line represent an equilibrium in the goods market, meaning that aggregate demand is equal to income. So in this graphic, I guess you can guess what is the equilibrium point. Can you guess it? Can you guess it? This straight line are all the points of equilibrium. Bisect. This is our aggregate demand. Did you see there is a point that very good, it's the meeting point. It was so hard. If this straight line represents all the equilibrium points in good market, it means that all the points of this straight line are an equilibrium of the good markets, and all the other points that are not on the straight line means they are not in equilibrium. So, if this is our goods market, when it meets the bisects, it gets the equilibrium. Meaning that we will have the equilibrium income and the aggregate demand of equilibrium. Okay?